Good morning, students. So welcome back. So today we are going to study the 10th topic, indices. Suppose if a is any rational number and m is any positive integer, then the product of a m times can be written as a raised to m. For example, a into a dot 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 m times. So that can be written as a raised to m. So what it means, if we multiply a m times, so we can express it as a raised to m. Here a is called as the base and m is called as the index or power, or it is also called as exponent. Okay. Now, so you have studied this, right? Now, the laws related to them. So the first law, rule for the product of index numbers when the numbers have the same base. Okay, so that is a raised to m into a raised to n is equal to a raised to m plus n. So if a is any rational number and m and n are any positive integers, then a raised to m into a raised to n is equal to a raised to m plus n. This is also called as law of multiplication of indices. Okay. Then second, rule for the quotient of index numbers when the numbers have the same base. Okay. So these bases are same. Again here a is any rational number and m and n are positive integers. Then a raised to m divided by a raised to n is equivalent to a raised to m minus n when m is greater than n. Okay, and a raised to m divided by a raised to n is equivalent to 1 upon a raised to n minus m. This is when n is greater than m. Okay, so this is called as law of division. Now third, next, rule for index of the exponent. Okay, so for example, if a raised to m is whole raised to n, then how we can write a raised to m into n. Okay, so this is third law of indices. Now fourth law, rule for the index of the product of the numbers. Okay, so for example, a and b are any rational numbers and m is any positive integer such that a into b whole raised to m, then that is equal to a raised to m into b raised to m. Okay, so this is fourth law. Then fifth law, rule for the index of a number in the a upon b form. So fifth law, a and b are rational numbers and m is any positive integer, then a upon b whole raised to m is equivalent to a raised to m upon b raised to m. Okay, then next, sixth law, rule for determining the value of a non-zero rational number when the index is 0. Okay, now here a is any rational number and such that its index is 0, then a raised to 0 is equivalent to 1. A raised to 0 is equivalent to 1. Okay, so these are 6 laws. The next law, rule for converting a negative index into a positive index. Means suppose a raised to minus m, 7th law, a raised to minus m, I can write this as 1 upon a raised to m. Okay, now suppose if I bring this to this side, what I will get? A raised to minus m into a raised to m is equal to 1. When you get the product of two numbers 1, what are they called? Oh yes, of course, they are called as multiplicative inverse of each other. So, indices with opposite power, with opposite signs and same powers, they are multiplicative inverse of each other. So suppose if I get 10 raised to minus 7 into 10 raised to 7. So what it will become? Minus 7 plus 7. So that is 10 raised to 0, and 10 raised to 0 is 1. And hence they are, yes, they are multiplicative inverse of each other. You get product 1. Okay. Then these are the rules we are going to use, or laws we are going to use for solving the examples. Then next we are going to study expanded form of the number. See here, in some cases it happens that the numbers are too large and it becomes difficult to remember them. For example, distance between sun and earth, very big number. Then how to remember? So we can express that number in the form of powers of 10, and it will be easy for us to remember it. Or diameter of oxygen, very small number. How to remember? 0.000000. कैसे याद रखेंगे भाई? तो इसके लिए we will use powers of 10. That is expanded form of numbers. We'll write it that in that form. Yeah, we'll express the numbers in the powers of 10, and it will be easy for us to remember that numbers. Let us see that. Now see, expanded form of numbers. So in that we need powers of 10. Now we know that 10 raised to 0 is 1. Then 10 raised to 1 is 10. 10 raised to 2, 100. 10 raised to 3, 1000. 10 raised to 4, what it will be? Yes, 10,000. Okay, and 10 raised to 5, what it will be? 1, 2, 3, 4, 5, 1 lakh. Okay, and so on. Suppose if I go for the negative powers, means if I divide this 1 upon 10. Now 1 upon 10 means 10 raised to minus 1. Negative power. Okay, then 1 upon 100. So I can write it as 10 raised to minus 2. 1 upon 1000. 10 raised to minus 3. 1 upon 10,000. 10 raised to minus 4, and so on. So these powers, they expressed, okay, in this way, in the powers of 10, these numbers, and that helps us to express very large numbers and very small numbers. For example, now see this distance between Saturn and Uranus. So you can see two big numbers, 14390000000000. Try to read it. Okay. So how to remember this? Now in that case we can express this in the form of powers of 10, and then it becomes easy. But at the same time, whatever the numbers are there now, they are expressed within 0 to 10. They are expressed within the range of 0 to 10. See here, means what? I'll write this number as 1.439. Okay, so 0 to 10. So it comes within that, 1.4. Okay, now, so decimal point is here, right? Now, means what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 10 raised to 12 meters. 1.439 10 raised to into 10 raised to 12 meters. So what I did, decimal point is here now, it has been shifted here. Okay, so how many places? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1.439 10 raised to into 10 raised to 12 meters. Okay, I hope you have understood. Now, so here, see this diameter of oxygen atom. Now if you see the diameter of oxygen atom, this is very, very, very small. How to remember that? So 0.00000000000000 356 millimeters. Very small. So again we are going to express it in the form of powers of 10. So here it should come here. Decimal point should come here. 3.56. So this decimal point is going to shift here. Okay. So what I will do? 3.56 divided by. Okay. Now this is smaller number, so that the powers are going to come here. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So see how many zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So that is equal to 3.56 upon 10 raised to 14. So that is equal to 3.56 into 10 raised to minus 14. Powers comes up. Same way you can show it here also. 1.49. I'll just explain here again if you want. So this I can write it like this. Decimal points come here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So then I can write it as 1.439 into 10 raised to 12 meters, and here millimeters. I hope you have understood. Okay, so let's move to the next example. Now exercise 10.1, second example. 3 raised to 4 into 2 raised to x is equal to 36 square. Now if you see here it is 3, here it is 2. Means 36 I have to express in that way. Okay, so find the factors. So see how I do it. So suppose if I write 3 raised to 4 into 2 raised to x, 36 I can write it as 6 into 6 whole square. Okay, and now this 6 into 6 I can express it as 2 into 3 into 2 into 3 factors. Right? Now see, 2 raised to 2. 2 into 2 means 2 raised to 2. 3 into 3 means 3 raised to 3. Okay, 3 raised to 2. Okay, so 3 raised to 4 into 2 raised to x, that is equal to 2 raised to 2 into 3 raised to 2 whole raised to square. Okay, now, so 3 raised to 4 into 2 raised to x, that is equal to 2 raised to 4 into 3 raised to 4. 2 2s are 4. 2 2s are 4. Now see, 3 raised to 4 on both the sides will get cancelled. So left is 2 raised to x is equal to 2 raised to 4. So therefore x is equal to 4. So value of x is 4 exactly. Okay, so option number 1. Option 1 is the answer. Okay, now let's move to the next example. Now see third one, you have to find the smallest numbers amongst these numbers. So 0.1 raised to 4 into 15, 0.00015 into 10 raised to 2, 150 into 0.01 whole square, and 1.5 into 10 raised to 3. So what we will do? We will straight away do it like this. See, 0.1 raised to 4 means what? 0.0001 means 0.1 into 0.1 into 0.1 into 0.1. 1 ones are 1. Decimal point after 4 digits. So 1, 2, 3, 4 into 15. Okay. Now this I can write it as 15 ones are 15. And decimal point after 4 digits. So 1, 2, 3, 4. So 0.0015. Okay. Now this I can write it as 0.00015 into 100. 10 raised to 2 means 100. So decimal point will shift towards right hand side by 2 digits. So this will become 0.015. Okay, it will come here. So 0.015. Now this will become 150 into 0.0001. Square of 1 is 1. But in this number after decimal point there are 2 digits. So So in its square, after the decimal point, there has to be 4 digits. So 1, 2, 3, 4. Okay. Now here, 150 ones are 150. Okay. Decimal point has to be after 4 digits. So 1, 2, 3, 4. So 0.0150. Okay. And then last number, 1.5 into 10 raised to 3 means what? 1000. So decimal point will shift 3 digits towards right hand side. So it will become 1500. So 1500. So which is the smallest? Now if you see this, these are similar. Okay. Now here, see this. This is the smallest. It is 0.0015. Okay, so 4 digits. So option number 1. Option 1 is the correct answer. Okay. So let's move to the next example. Now see, fourth example, which of the following does not represent 1024, that is 1024. Now if you see here, 10.24 into 10 raised to 2, definitely 100. So when you multiply by 100, it is going to be 1024. So it is correct. Now here, 4, 5 times. Okay, means what? 4 into 4 into 4 into 4. Okay, 5 times. So 4 4s are 16. Okay, and 4 4s are 16 and multiplied by 4. 16 16s are 256. Multiplied by 4. 6 4s are 24. 2 carry on. 5 4s are 20 plus 2. 22. 4 2s are 8. 8 plus 2 10. So it is. Okay, keep this. Don't go for this. Go for this. 5 raised to 4. When 5 is there in the decimal point, in the units place, there is always going to be 5. You can check it. 5 into 5 into 5 into 5. 5 5s are 25 and 5 5s are 25 and 25 25s are 625. So which is the option? Yes, option number 4. Option number 4 is the correct answer. That does not represent 1024. 2 raised to 10, it will represent 1024. Okay. So next example. Now see fifth example. 81 is equal to 27 raised to x. What you do here, bring it to the same base. Base, if it is same, then it becomes easy to solve. So 81, I can express this as 3 into 3 into 3 into 3. Okay, 3 3s are 9, 9 3s are 27, 27 3s are 81. And 27 I can write it as 3 into 3 into 3 whole raised to x. I hope you understand. 3 3s are 9, 9 3s are 27. Okay. Now this becomes 3 raised to 4. That is equal to, this will be 3 raised to 3 whole raised to x. Now see, bases are same. Okay. Now, so 3 raised to 4 is equal to 3 raised to, law of indices, a raised to m whole raised to n is equal to a raised to mn. Okay. So 3x. Now, so bases are same, so neglect the bases. Neglecting the bases. So what you get? 4 is equal to 3x. So therefore 4 upon 3, that is equal to x. That is, x is equal to 4 upon 3. So option number, x is equal to 4 upon 3, option 4. Okay. So that is the right answer. Now let's move to the next example. Now see, 25 raised to minus 3, raised to 5, raised to 0, raised to 13. Now we have studied the law. A raised to m whole raised to n is equal to a raised to m into n. So definitely this means what? 25 raised to minus 3 into 5 into 0 into 13, that is equal to 0. That is equal to x. Okay, now here minus 3 into 5 minus 15, minus 15 into 0, 0, and 0 into 13, 0. So 25 is to 0, that is equal to x. So 25 is to 0 is 1, that is x. So value of x is 1. So option number third. A raised to 0 is 1. So 25 raised to 0 is 1. Okay. So option third. Now next example. Now see 2 raised to 8 into 2 raised to minus 2 whole raised to x, that is equal to 32. So what do you do? Bring the power of 32. Make the base of 32 same. Means 32 express it in the form of indices. Okay. So this will law of multiplication. 2 raised to 8 plus minus 2 whole raised to x. Now this 32 I can write it as 2 raised to 5 because 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32. So 5 power, 2 into 2 into 2 into 2 into 2. Okay, 5 times. Okay, now this is what a raised to m into a raised to n is equal to a raised to m plus n. Okay, so this becomes 2 raised to 8 plus into minus minus whole raised to x. So that is equal to 2 raised to 5. Now 8 minus 2, 6. So 2 raised to 6 whole raised to x, that is equal to 2 raised to 5. Now so 6 a raised to m whole raised to n, that is a raised to mn. So 2 raised to 6x, that is equal to 2 raised to 5, neglecting the bases. What you will have? 6x is equal to 5. Therefore, x is equal to 5 upon 6. So option number 4. Okay, so that is the correct answer. So dear students, we'll stop here today. Your today's homework, go through the topic, write down all these examples in your notebook, and we'll continue in the next video. Till then, goodbye. Have a nice day. Thank you.